What is ozone O3 and its role in the polar regions? Imagine a thin, invisible shield high above the Earth that blocks out some of the sun's most harmful rays. That's what ozone does in our atmosphere. It is a molecule made of 3 oxygen atoms, and it's mostly found in the stratosphere, which is about 10 to 50 kilometers above the surface. This layer is vital because it absorbs most of the ultraviolet radiation from the sun, protecting all living things on Earth. In the polar regions, ozone's role becomes even more interesting because of the extreme conditions there. During the winter months, especially over Antarctica, the ozone layer can become very thin, creating what is called the ozone hole. This thinning happens because of a combination of natural and human-made factors. Human chemicals like chlorofluorocarbons or CFCs, which were once common in refrigerants and spray cans, rise into the stratosphere. When exposed to ultraviolet light, these chemicals releases chlorine and bromine atoms that destroy ozone molecules. Normally, ozone is constantly being formed and broken down in a natural balance, but these chemicals upset that balance. Over Antarctica, the cold winter temperatures are especially important. The air over the continent is very cold and forms clouds called polar stratospheric clouds. These clouds provide surfaces for chemical reactions that turn inactive chlorine and bromine into reactive forms. When spring arrives and sunlight returns, the ultraviolet radiation triggers rapid ozone destruction. This causes the ozone layer to thin dramatically, creating the ozone hole. The size of this hole can reach up to 20 million square kilometers, which is about the size of North America. The ozone hole peaks in late September or early October and then gradually recovers as temperatures rise and the polar vortex breaks down. The Arctic, or the northern polar region, also experiences ozone depletion but usually less severe. The Arctic's winter temperatures are warmer, and the polar vortex is less stable, so fewer polar stratospheric clouds form. This means less chemical reaction and less ozone destruction compared to Antarctica. Still, in some years, significant ozone loss has been observed in the Arctic. The seasonal thinning of ozone has real effects on the environment. Increased ultraviolet radiation can harm marine life like phytoplankton, which from the base of ocean food chains. It can also affect animals and humans living in these regions. Efforts like the Montreal Protocol, an international treaty, have helped reduce the use of ozone-depleting chemicals. As a result, the ozone layer is slowly recovering, but the Antarctic ozone hole is expected to last for many more decades. So, in the polar regions, ozone acts as a shield against harmful UV rays, but extreme cold and chemical reactions can cause it to thin out seasonally. Understanding these processes helps us see why protecting the ozone layer remains so important for the health of our planet.